engineering teams always want to know where should they focus their time on, right? Should they be writing more integration tests? They be writing more end-to-end tests? What is the right mixture there, right? So our philosophy there is in this microservices world, there's a lot more dynamic interactions between components, right? There's a lot more API calls that are, and it's generally chatty. It's like, a service typically talks to many other services and other databases and stuff like that. So I would always recommend really focusing on integration testing.
Welcome to the DevSec for Scale podcast, the show that makes security a first-class citizen for growing companies. My name is Jeremy Hess, Head of Developer Relations at Achilles, the secrets management SaaS platform. Welcome back, everyone, to the DevSec for Scale podcast. I'm Jeremy Hess, Head of Developer Relations at Achilles, and with me today is a really cool guest. His name is Arjun Iyer. He's the CEO and co-founder of an awesome startup called Signadot, and they do something really cool in terms of microservices testing that I didn't know existed. So it's really good to have you on the show, Arjun. And before we get into a little bit about yourself and what you've been doing and what you are up to now, let's just get straight into it. What would you say were the history sort of testing, integration testing, E2E testing from the earlier days, and then moving to like sort of the agile methods, and then today to microservices?
Yeah, thanks for having me on the show, Jeremy. It's great to be here. That's a great question. So let me just recap a little bit about how it used to be done in the monolithic days, right? When applications were built as in a monolithic fashion. So typically you will have, a simple tier like a front end, a middleware, and probably a database on the back end. And typically you can test the whole application as a whole, right? So it's very easy to test the whole application entire end to end. So that's where the focus used to be, right? A lot more end-to-end testing, and obviously there's unit testing and other things, but mostly it was end-to-end testing that would be done on such a monolithic application, right? With the need for sort of like, as engineering organizations grew, companies started to break up the monolith into smaller pieces, typically referred to as microservices, so that you can actually ship each component independently of each other. So now this gave the engineering teams a greater velocity, and they can actually make changes in a more fine-grained manner within the overall application, and they can fine-tune the scalability and other things at a component level, not at the application level, right? So this was great to sort of like increase the velocity of the whole organization. But this introduces a lot of issues when it comes to testing, because now, even though each component is being developed and released independently, they need to be tested as a whole to really get that confidence that it works, right? Because your end users perceive the application as a whole, right? They want to see the end-to-end flows working for the end user as a user would use the application, right? So that's where the challenges come into play, is how do I maintain that balance between me developing independently and moving fast, and at the same time, not introducing regressions or getting a much higher degree of confidence that my change hasn't broken any core workflows that an end user would face as early as possible, right? Because me as a developer would like to get that indication much earlier, rather than finding some issues at like just before releasing to production, or worst case in production, right? So that sort of is how I see the testing landscape, the challenges that are introduced by the introduction of these sort of decentralized applications.
Great stuff. So we're going to talk a lot more about getting into the weeds of microservices testing and things like that. But before we get there, why don't you go ahead, Arjun, and just introduce yourself. Tell us about, where you come from, what your background is, and how you got to Signadot today.
Sure. As you know, my name is Arjun Iyer. I'm the CEO and co-founder of Signadot. Before Signadot, I used to work at AppDynamics. So we are a big player in the APM space. So very well versed with the observability space in general. So I spent about 5 years there. I built out the, internally it was called analytics, but externally it was called Business IQ as the product and the platform. So I built that from ground up, scaled that to, by the time I left after the acquisition by Cisco, that itself was doing more than 100 million in ARR as a business. So it was a pretty successful product within the overall AppDynamics suite of applications. So that's kind of where my team built everything cloud native. We were one of the early teams to build everything in the cloud using microservices, and later shifted everything to Kubernetes. And that's kind of where I sort of hit this problem. My team was spending far more time than I would have liked dealing with these kind of issues, integration issues and other issues, like very, very late in the process. Like they would spend a lot of time either in production issues or finding things on staging, which really, took away a lot of cycles to work on the new features and new innovate on improving the lives of our customers. So that was where we started to think about, like, why was it happening that way, right? And that led to the foundation of Signadot. So, we are tackling this problem of developers not being able to be creative enough in their day-to-day job because they are pulled into so many other things, like, for example, debugging a staging issue or something like that, which sucks up a lot of developer cycles, right? So that's what we're fixing at Signadot.
Great stuff. Great stuff. So let's get back into the testing itself. We're talking about Kubernetes at this point. Microservices, there's kind of synonymous these days with Kubernetes. Yeah. And obviously Kubernetes is not a simple tool. It's complex, especially now that you're talking about having to test all the various pods and make sure that they're keeping up with everything else. So can you give us a little bit about sort of like what makes it more complex to test in a Kubernetes type of environment, things like tracking the changes to all the services and all the other issues that come up?
Yeah, like I mentioned earlier, it's kind of like the application is broken down into smaller pieces that move independently, right? So if I'm a developer working on a few microservices, but the application is composed of, let's say, 50 microservices, then I need to make sure that I test against the latest versions of all those other components, right? I may be working on just 2 or 3 services at my end, but there are 47 other services that I depend on, right? Including cloud resources, like databases and message queues, and they could be potentially third-party APIs that I depend on and the application depends on. So all of that needs to be set up in an environment, right? So, and that's kind of the main challenge that I realized, is that developers don't have these access to these environments where they can actually test their changes, where they get very high degree of very high quality feedback, right? I can definitely write unit tests, and I can run some simple integration tests in a CI environment, but those are usually like very local and very limited, because they're usually mocked and they run in a very mocked up and a fake sort of like environment, in the sense it doesn't really reproduce the behavior that I would see in production, right? So even though that may be necessary, it is not sufficient, right? So so that's kind of what we felt is the lack of environments is the main reason why developers find it very hard to really understand or really test their changes much earlier in the life cycle, right? So that's kind of the main thing that makes it challenging. And of course, the actual intricacies of Kubernetes, it's a separate thing. Definitely it has made operationally the lives of DevOps and infrastructure folks much, much easier, for sure, by automating a lot of things that you don't need to worry about anymore. But the lives of developers are not necessarily simplified, right? There's still a lot of learning curve to understanding how Kubernetes works. And so what developers need is a very simple interface, right? Like, because they are working on mostly the application layer. So they want to be able to hey, I've written this service or a bunch of services. Now, how do I test them in this platform, right? So that's kind of where I feel there's a little bit of that disconnect, where the user experience is not necessarily where it needs to be when dealing with systems like Kubernetes.
Absolutely, absolutely. So, we're talking obviously about testing on a staging level, because we're trying to shift everything as left as possible. And, if that wasn't obvious to anybody, I'm just saying it out loud. And, so what is what are like the difficulties? I mean, in a staging environment, we're talking about an environment that lots of developers are working on at the same time. And so, I feel like maybe it kind of could create some sort of, like a noisy neighbor type of problem. I mean, it's a slightly different scenario, but just the idea is kind of similar. How do you protect against that? How do you work, with so many people all at the same time?
Yeah, that's one of the fundamental issues that we see when companies rely on a shared staging environment, right? The fact that it is shared, now you're going to have developers bump into each other because they're all using it as a testing platform. And whenever you find issues, you're going to roll back your changes, and that's going to cause disruption to other teams that are relying on that environment to test their changes, right? And also, it's another issue that we see is even troubleshooting or root cause analysis of why some regression happened is not so trivial because you have so many changes going into that environment from different teams. So even though it may seem like your services where the failure occurred, it may actually be some other team's changes that are the root cause of the issue, right? So that we've seen that also take up a lot of time, valuable time, where developers are spending hours troubleshooting why staging broke, right? So these are the couple of changes we've seen. So fundamentally, I think what is missing is, like you said, the lack of isolation, right? So you need to have an isolated environment where individual developers or individual teams can actually test in isolation and be able to test independently their changes without impacting others, right? So that isolation is key here. However, just the brute force approach of, okay, maybe cloning a staging environment is a brute force approach. Like you can say, I'm going to give every team their own staging environment, right? That does solve the isolation problem, but it comes at a very steep cost, right? So these staging environments are not easy to clone. Like it's very expensive because of the number of services involved and number of cloud resources involved. Databases are to be set up, and there's so many interconnected pieces that need to be spun up to clone that environment. So it's kind of like, companies are stuck between a rock and a hard place, in the sense, either you throw money at the problem and sort of have independent environments, or you're stuck in a shared environment, which is very difficult, people are going to block each other.
Yeah, well, and on top of that, the next thing, not just affecting each other, but also trying to test against an environment that's not necessarily connected to where you are. If you're just working on a small piece, a feature, have a small change to make, you also want to make sure that you're testing against the latest environment, right? So how do you make sure that you can still test against that latest environment without actually having to clone the whole environment and then run tests?
Yeah, and that's a great point, because that is something that we see, especially in this dynamic environment where every microservice is independently being changed. You're working on a few pieces, but all the other pieces are changing as well, right? So how do you ensure that your test is valid? That is, you're always testing with the latest versions of all the dependencies. So that is a very key issue as well. And that also is not addressed by the cloning solution, because now all the clones need to be kept up to date, which is another maintenance nightmare, right? You got to keep every staging environment or every QA environment up to date with the latest version of the main branch or the trunk branch. So that's the other challenge that we see companies run into as well, where if you're testing on a stale environment, your test itself is not valid anymore.
Absolutely. So, and that's actually something, I usually don't get into the technologies of the companies, but because I find Signadot such a fantastically cool technology, why don't you give us a little bit about how actually Signadot handles these situations?
Absolutely. So at a high level, there are a couple of intuitions that we base the solutions on. The first intuition is that, in the microservices world, typically you have more frequent changes, but smaller changes, right? So the change that you want to test are, probably will touch, a few microservices at a given time, maybe just one microservice most of the time. So in that case, what we could do is, or rather what we do is we only spin up the things that have changed. So think of it as like, technically you can think of it as a copy on write model, right? So that's kind of what is used in memory systems and things like that. So similar philosophy of like, just duplicate or copy the things that have changed, but keep the rest of the environment the same, right? So that's one sort of like intuition, how we spin up these environments called the sandbox environments, right? So essentially that's how Signadot works, is it allows you to spin up sandbox environments that are all co-located on a single Kubernetes cluster, right? So you can install you can install Signadot on a staging cluster that you already have and be able to spawn these lightweight ephemeral environments called sandbox environments. And the intuition, like I said, the sandbox environments only spawn the things that have changed. So it makes it very easy to bring up an environment very, very quickly because it's only spawning a few services and potentially databases that have changed or that need to be tested together. The other intuition is that of isolation, right, which we talked about earlier. And that's a very key aspect because you want each of these sandbox environment to be able to support testing independently, right? So there, what we use is we use application level multi-tenancy to actually route. It's basically done at the request level. So we share the resources between the environments, or we share the services between the environments, but the test requests that flow through the services are isolated based on which sandbox they're targeting, right? So we have the ability to dynamically route the requests to different sandbox environments. And by using dynamic routing, we allow different requests to be isolated to different sandboxes, right? So that way we get the isolation aspect of it, and it's tunable in the sense, and what I mean by tunable is you can decide to include more pieces if you want in your sandbox for greater isolation. Like an example is, if I am a developer making a change to a database schema, I might not only want to isolate my service, but I also want to isolate that database, right? So we have a plugin framework that allows you to spin up an ephemeral schema or an ephemeral resource that is tied to the lifecycle of sandboxes. So this way I can actually spin up just my service and my database and still be able to test in a complete environment.
So yeah, this actually is also the other interesting part to me is how a developer, let's say, who's making a change right now, is sort of, there's someone who made an earlier change, let's say 2 minutes ago, and then the whole environment changed. This person's in the middle of updating a small feature, whatever it is. How are they getting a live synchronization happening as they're coding, saying, oh, there's a change that's happened, go ahead and, pull the branch again, to see that the changes that were made? Or how does it synchronize with that?
Yeah, and we get that because Signadot is installed in an existing cluster, right, which has the baseline application running. So that environment, typically it'll be like a staging cluster or staging environment where it's continuously updated using a CI/CD process based on the main branch of every microservice, right? So because we are basing this sandbox environment on that same physical cluster, we automatically get this ability to always be having the latest version of the baseline, right? So no matter, even if I have like some other check-in go into that environment 2 minutes ago, my sandbox is already using that latest version of the service, which is deployed in the baseline cluster. And then my sandbox will still have the components that is still under development, right? So it will still have those versions coming from a dev branch or something like that. But I'm actually guaranteed that I'm always testing against the latest version of the dependencies.
Really cool. The next question I have about sort of this topic really is talking about how does integration and E2E testing kind of, especially in microservices, how does it help the overall health of an organization's environments?
Yeah, that's a great question. So there's two aspects to it, right? In terms of like engineering teams always want to know where should they focus their time on, right? Should they be writing more integration tests? They be writing more end-to-end tests? What is the right mixture there, right? So our philosophy there is in this microservices world, there's a lot more dynamic interactions between components, right? There's a lot more API calls that are, and it's generally chatty. It's like, a service typically talks to many other services and other databases and stuff like that. So I would always recommend really focusing on integration testing, because that really tests those sort of linkages pairwise linkages between services, right? That's kind of where the actual dynamic behavior can be tested. And, you want to test that in a real environment where you get high degree of testing signal, right? With the right data set, preferably as close to production data set as possible. So that's kind of where we make it very easy to do that by spinning these sandbox environments, because you can do it on the fly. And you can hook it up with the CI/CD process to automate it, right? It's because the only sustainable way an engineering team can scale testing or scale coverage is if you automate it. Like, it's very difficult to keep up doing this manually beyond a certain amount of time, especially for regression testing, right? So I think that's kind of one area where we really emphasize the need for integration testing a lot more. End-to-end testing is also important, just because you have some core user flows that you don't want regressed. So in that cases, I would say the bulk of the testing should be integration tests, and those can be decentralized. Like, each team can have their own integration test that very nicely decentralizes based on the APIs of the microservices that each team or or developer owns. And that is so nicely decentralizable within the organization. So you can actually scale that up within the organization very, very easily, right? So that's a reason to really write more of integration tests. End-to-end test, again, there's an ownership issue, like who owns the end-to-end test, right? Is it a central team? Is it a QA team? So there's a little bit of, is it a front-end team? So our guidance is you should definitely have a suite of end-to-end tests that tests very core user flows, like the critical user flows. Like, if you're an e-commerce site, you want to make sure that people can actually search for products and buy it, right? Like, that flow is such a core flow, right? Whereas if a recommendation recommendation doesn't work, it's not such a deal breaker, right? So identify these core flows of your application and have end-to-end tests that test those core flows, right? And these core flows can be, again, tested using sandbox environments, which allow you to do end-to-end testing as well, right? But you don't want to have too many of end-to-end testing, because they can be fairly brittle, because they span the complete end-to-end sort of like flow from the front end to several backends. So you want to limit it to the core flows of the application that you want to make sure that hasn't regressed.
Great. So that actually kind of is an answer that you could give me for my last question, which the last question I like to ask all my guests is, what sort of ideas and tips would you have for developers today who don't necessarily have as much time to focus on security, but kind of what are some tips that you can give them that can help them, focus on or get best practices sort of in security while still making sure that they're able to get all their work done?
Yeah, I would strongly recommend a shift left thinking there. So as much as you can do, before you even merge code, right? I think that's the place you want to focus on as much as possible, like using linters and other security tools that can actually check your code in a static analysis of the code, as well as potentially using, dynamic runtime analysis as well, right? That could potentially be done either using tools like Signadot or other tools as well that could be done as well on the runtime aspect. But at a high level, I think the more you shift left, the better it is, because much cheaper to fix it at that phase. And you want to be in the flow while you're actually, as you're developing the feature or the functionality that you're actually coding up. That's the place where you want to find these issues and be able to fix them on the fly. Like, you don't want to have a disconnect where you're finished coding and then you realize that something failed much later in the process, right? So I would highly recommend the shift left philosophy, even especially in terms of security checks and other best practices. And that is something that can scale within an organization as well. So if every developer or every team has a shift left sort of mentality and philosophy, that scales very nicely as the engineering team scales. So yeah.
Fantastic. Perfect. Arjun, it was great to have you on the show. And I want to wish you best of luck with Signadot. Really cool product, great technology. And I hope that we can have a potential follow-up later down the line to see how you're doing and how the company is doing. So thanks so much for your time. I really appreciate it. And to everybody listening, stay secure. Thanks so much, Arjun. Have a good one.
Thank you so much, Jeremy.